See your physics tutor, as you all know that we are still on our Waec 2025 preparation. We have done a lot of experiments on magnets, lights, and electricity. Today, with electricity update experiment. Remember that was the last video we made on the electricity. That one also went viral. It was so funny that we saw many views, thousands of views, but we only received 1 or 2, let's say 1 to 5 numbers of subscribers. Please do well to subscribe as you are watching our videos. And we also appreciate that your comments that we always give every day. Those of you that have given us comments, especially our professional colleagues, we saw your comments. The last video, some people requested for circuit diagram. Circuit diagram we have it now, and likewise we have the experiment. Now this we want to make this will be part 2 of the video you just saw that's trending right now about the electricity. So we are still on the requirement of Waec. We have potentiometer. I have my potentiometer with me here. And when you talk about potentiometer, what is its function? You can see I say here potentiometer is to adjust the voltage. You can see it's to adjust the voltage and connect what the electronic circuit, my wire, everything connected on my potentiometer what will be for that example. And number 2, I talk about rheostat. What is the purpose? This is my rheostat here. This one is connected. This is my rheostat. What the purpose of this rheostat? I say it's a variable resistor, and what it does, it controls the current flow in the circuit. That's why I say control the current flow in the circuit. When I'm adjusting it, the current flow will be controlled. And number 3 that I have here is the cell, the source of the current, that is measured in voltage. That's why cell is what is used to provide the electrical energy. And this is used to provide electrical energy and drives what the current. I don't want to waste and I want to make the video very short. Voltmeter, I have my voltmeter with me here. What it does, we use to measure the voltage, the potential difference of a particular cell. I have my cell here. When I start the practical fully, I will check the EMF of this particular battery that I'm holding. I move to the next one that I call ammeter. This is my ammeter, it measures current. Ammeter measures current. I don't know how to waste time. Jockey, I have my jockey here, and this is my jockey working very effectively. And what the purpose is two that make a contact. You make a contact with my potential difference. I get my language now to measure my potential difference or the potential difference. And second to last, I have my key. This is my key. I have another one here. I have my key. Now this here is the position of controlling open and closing of the circuit. As you have your switch at home on and off. That is where I'm also controlling it. And remember, it's one of my precautions. Whenever I'm going to carry out experiments, this must be opened. When it is closed, this is closed. When it is open, there won't be any movement of current. And lastly, second line, I have my standard resistor. Resistor that has value. This is 1 ohm. Like it has been requested, that's the standard resistor. It has 1 ohm. That's what we need to be called standard. And what it does to limit what? To limit my flow of current. Is one opposing the current. Definitely you need to limit or to reduce the flow of current. And I pick the last of wire. Everybody knows wire. We have a wire everywhere in the world. Now this wire is the parts. What is it? The parts where the electrical current will pass. So that's the reason why I first of all did the introduction. Then knows the meaning of all these things we have here. So the next thing will now be how will our experiment be. Now, looking at my circuit here, I will soon write the instruction that we are going to follow to make sure these things we have on the board is achieved. But we can also see, if you check very well, I have my circuit diagram and likewise I have this my experiment on my board here. So let me describe it. You can see myself. The positive side is connected to the rheostat. The positive side is connected to my rheostat. You can see the positive, where is it? This is my battery. I will connect this to this. But I don't want to connect right now. Let both of us measure that. Whenever you are doing practical on electricity, the first thing you must do, measure the EMF of your battery. You must measure the EMF. That's what I want to do right now. You are watching me. Let me show you my positive goes to the positive. My positive goes to the positive so that you can see the EMF. And my negative goes to the negative. This is my positive, my negative, negative. You can move closer camera to see. What is it? You can see my potential difference. You can see my potential difference there from my readings. What I'm seeing right now, though I'm checking from the far off here, I think I'm seeing something like 2.8 because it's not new, it has been used already. It has been used before now. Maybe I should make it fix a little. Okay, I have 2.8. Yes, I have 2.7. If camera can see very well, from where I'm viewing it, I'm seeing 2.7 or 2.75 from where I'm viewing it. You can see very well. All right, that is, I've known my EMF. That is, anytime you are doing practice and you write it down, your E naught, like the one we got down, maybe 2.7 or 2.80 volts. That's the EMF of this particular version. You know, it's 1.115, it's supposed to be 3 volts, but because it has been used a little bit, that's why currently the EMF is 2.8. Now, let's now start the connection. I have my battery here. My battery, the positive side should be connected to the rheostat. The positive side will be connected to the rheostat. Camera move closer to me so that they will see how it is connected. I'm also watching my time. I don't want the video to be too long so that we will be communicating. All right, I have connected the side, another side also of the rheostat that we connect. Now, look at something here. All these lines you are seeing are wires. There's a wire coming from rheostat. Camera, see my hand. There's a wire coming from the rheostat going to the potential, to my potential difference. Another one is that I have another wire coming from voltmeter. Here is my voltmeter. Here is my voltmeter. Another wire is coming from the voltmeter. If you check that wire again, also going to this particular place called potential meter. And I have another one coming from my 1 ohm resistor, also going to the potential meter. Tell you that we have 3 wires going to the potential meter. If you like, I can mark them as one. If you like, I can let the 3 meets on the potential meter. We are all saying the same thing. Thank you. That's for that side. I'm still on my connection. Now, the second hand of the voltmeter, I'm talking about the negative side of the voltmeter. That one will go to this point to meet my switch. My switch is coming from my ammeter. The other side of my cell, the negative side, that one will go to the negative side of my ammeter. So let me do that for us to see. So the negative side of my battery going to the ammeter. Now from ammeter to my key, you can see that from ammeter to my switch. Remember, it's open because I don't want my battery to run that. Coming again, the whole meter at this point. That is, there is a wire here for me. I have the wire here. I'm holding. I have another wire from voltmeter that is also meeting here. See my voltmeter? You can see the wire coming from voltmeter also meeting there. But remember, not the one that was the third wire. The third wire is my jockey that will go here. This is my jockey. So this is a complete connection for this particular circuit diagram involving all the requirements that our head want us to supply for this year physics practical. Everything is we have it there. So we have everything available here, and everything is useful and used the way we are expecting question to come out. The next thing will now be in the question. I will bring out the question. I will write the question out. The question will now be they will be giving us particular values of length. But before you go there, since you have rheostat, and whenever you are talking about voltmeter and ammeter, definitely this is current, this is potential meter. This is already Ohm's law. You know that it's already playing Ohm's law there. And remember, this is my resistor. That is 1 ohm must be labeled. It will be unknown on the day of examination. If I have my practice now, I want to declare it to be unknown, that nobody will see what is there. So I have made it to be unknown right now as I'm speaking. So nobody knows the value. As I'm speaking right now, nobody knows the value of this resistor as it is there. So the next thing will now be, now I must know the maximum current. Through the adjustment of these rheostats. What can I do that one? Now get ready. You can see I want to close my key. And the experiment will soon start right away. Let me see if everything is intact. If everything is intact, definitely we are supposed to be ready to move. So that every one of us will see. My mission is to adjust my rheostat to make sure wherever it gives me the maximum current, that's my target. I will soon write the instruction, but I'm telling us what the picture of what we want to do to let us see how it's going to be. You can see I'm adjusting right now. You can see camera should focus on my meter reading. Now I want to adjust to see the role of the rheostat. When the thing records the maximum is where I will fix this thing. Where it fixed the maximum, that you can see that that's the position of my maximum point. That's where I will fix. And the question will now be telling me to be repeating the experiment. Now let me write the question and let's see how it's going to be. I will write the question right now. I think you have seen what I want to bring out from here and how the connection is and how it's going to work. Now let me put out the instruction that we are going to follow that will now give us a better understanding of what we are expecting in the Waec physics practical come 2025 and it's maybe next week right now. Okay, now let me have the question on the screen. Alright, thank you. Like we were discussing the other time when I told you that the function and the rules of these circuits, I said I would prepare a question to back it up. I have put it on the circuit before, and likewise I have put it in a real practical for you to see. The next thing is now to have a question to guide us. Like let's say a possible question, a likely question that they may ask us in why. That's why I prepare a particular question like that. You are provided with a potentiometer AB, potentiometer AB, a standard resistor RS. I told you this is my resistor. We will give the RS. Like I was saying, we have my instruction here saying that I have a standard resistor, a battery of 3 volts. You can see my battery when I check the EMF the other time, it was 2.8. Whatever the EMF is what you will write. If your own EMF is 2, you write it down because that is what will determine the measurement or whatever you are doing. So my whole is 2.8. Then I'm preparing my table, or let me show the reference of how my table will look like. Let me place my solution list. The first thing I will do, I will write my E naught or my EMF. Since I have gotten 2.8 when I measured, I have 2. This. Now let's move forward because of time. A jockey J and other necessary material. Here is connected as has been shown here. Close the key. Adjust the rheostat such that when the jockey is placed on B, when the jockey is placed on A, B, or B, anyone call it, it will show ammeter recording its maximum deflection. Camera closer to me. I want to show something now. I want to close my key. You know, this is my rheostat. When you can see for my adjustment, the thing has gone back to 0. Now I'll be watching my ammeter and my voltmeter. I want to adjust it to the maximum. Wherever I give me the maximum, that's where I will use throughout. Okay, it's like, okay, let me adjust again until where I have the maximum. It's like I have my maximum point at, what is that? If I'm taking, since they say we should use the word from 0 to 1 for the ammeter. My ammeter, this is my ammeter, from 0 to 1. From 0 to 1, let me pick the one that can be clearer. 0, 0.1, 0.2, 0.3. This is 0.5. That is my I naught, my peak. Because the section said record the value of current as I naught. My I naught is what? 0.5. You can see very well. The camera can also show for us. Okay, maybe I should come down to check to see if you are still there. Okay, it's like it is 0.55, 0.55, 0.6. Let me pick 0.6 or 0. Okay, I can see 0.6. Now let me pick 0.6 ampere. So I have written that as my maximum current. Now they said something. Keep this rheostat. I should not touch the rheostat again. Fixed on the position throughout the experiment. Move the jockey to the point D such that L is equal to 10 centimeters. Record the corresponding reading of the ammeter I and the voltmeter V. That is, at that moment now, I will record. Now, they say I should place on 10. Camera closer. I want to place on 10. I want to place on 10. Whatever I record, see there is what I will record for my voltmeter. But before I go there, let me prepare my column. That is, I need a section, table of values. Table of values. I have this. Okay, if you like, I can put serial number, but there's no space for me. Let me have, they say for 10, maybe 10.00 centimeter. I need reading for ammeter. I need readings for voltmeter as at now. So let me go to when L is 10. Let me measure from when L is 10. What will I see when L is 10? Alright, camera, go to my voltmeter. When L is 10, I'm having on my it's like I'm seeing. Let me move it closer to myself to see. I can see 0.55 as my volt. My volt is 0.55. Let me check my currents. I'm also seeing 0.55. 0.55, 0.55. 0.55, 0.55. That's what I saw. Now, they said I should repeat this procedure for when L is 20, 30, 40, and 50. So let me put that one there, 20.00, 30.00, 40.00, 50.00. Alright, let me go that when L is 20. Camera closer, when L is 20 now. When L is 20. When L is 20, I can see readings, I can see movements. Camera, watch my. Alright, let me join camera to see. I have 0.6, 0.6, 0.5, 0.6, 0.5. Here is 0.6. Voltmeter give me 0.6. And this one gives me 0.50. Are we there now? I move to when L is 30. I'm rushing so that the video will not be too long. Camera move closer. I'm measuring my 30 now. As 30, what can I see? You can see movement. I can see 0.7 at my voltmeter. I can see something. Wow, this thing is very interesting. It's like my ammeter is dropping, while potential, my voltmeter is increasing. 0.7, 0.4, 0.7, 0.4, 0.7, 0.4. I'm moving again. Camera move closer. I want to quickly rush to do what they said when it's 40. When it's 40. When it's 40, I have this one increase again. 0. I have yes, that is 0.8 and 0. I'm still having 0.4. I mean 0.5 here again. I don't know what happened there. That is 0.8, 0.5, 0.8, 0.5. I don't know what really happened there, but we are still going to verify what happened there. Let's continue. And the last one, when it's 50, camera move closer. At 50. Wow, my voltmeter is making me happy here. I have 0. Okay, that's 0. It's still 0.5. I'm still 0.5. I will know what happened there. I'm still 0.5 again, and this one is still 0.8. I want to verify some things. I have my values like this. I will assume that I've finished my experiment, but I want to verify what brought all those anomalies there. Now let's check to know what brought the anomalies. I want to do my verification starting from at 20 to see what has happened. At 20, that one is perfect. But let me check. Still on it. I'm still on it 0.6. My currency now. My current is 0. Okay. Now my current is now working perfectly. Now my current 0.55, 0.6 now. I think my current is now 0.6. I'm verifying. I want to know what happened. So I think I have 0.6 now. I have 0.6. Alright, I have 0.6. Let me go to 30 and let's go. The time 30. Because when you observe anomalies, you need to check. Because it also tells our graph. At 30. I have 0.55 at 30. I'm having 0.55. Let me check that for my current. Right, 0.55 current. Don't know, 0.55. Alright, I think we'll move forward. Let's quickly, I'm cross checking the rest at 40. That one's still 0.55. All right, thank you. For 20. For 20, I have, let me quickly go. For 20, you know, we are verifying. For 20, 0.6, 0.6, 0.5, 0.6, 0.5. When L is 30, when L is 30, when L is, I can see 0.7. And all right, when L is 40 because of time, 0.8 for this place, I can see, yes, 0.50, okay, no, 0. 0. I can see 0. What the camera is showing to me, I can see 0. From camera, I can see 0.5. Is that 0.5? Let me come and check from there. I can see 0.6. 0.6. I can see 0.6. Alright. Let me quickly move to when L is 40. The video will not be long. Okay. Voltmeter correct 0.8. And the current 0. Still 0. What in camera? I don't know what happened there. Okay. Okay, 0.4. That's 0.4. Let me check again. I want to know what's happening at the circuit side and the current side. Okay. These are measuring. Okay. Okay, I can see that 0.5. And let me measure the last one. That's for 50. Yes, thank you. Okay, at 50, still 0.8, 0.8, and here 0.45. All right, 0.4. That's 0.45. Yes. Since we have known this, it may be due to maybe the battery is running down and what happened. And with this now, we have clarified the issue of following the instruction given to us by this, say that we should keep this and do that. Now, back to the screen, the board, the station should evaluate N naught, N raised to minus 1, that is a centimeter minus 1, and likewise you find I over V. You know the units, I is current, ampere, that is this. Do they have ask any question again? No. And they ask us to plot the graph of I over V on the vertical axis and L naught on the horizontal. At least our graph will look like something like this. Camera should look like that. Our graph will look like something like this. And this our I over V. I'll place the unit there. I over V, that is A over V at the minute. And L raised to power minus 1, that is Cm. This by minus 1. And I hope we don't forget the first thing, tie 2, everything, pencil on graph, tie 2. You have your tie 2, you have your scale. You plot your graph, you find your slope. When you find your slope, maybe any of your slope look like, if it equals for intercept, and if it doesn't equal for intercept, if it is origin, whatever how the situation look like, we plot the graph. And from there, we also answer the remaining thing they say from the graph. You should evaluate L. You know, you may not see L, but you see L is for minus whatever. You know what it means to get your L. You take precaution. You can see, you carry out the experiment, you can see the precaution. Number 1, the precaution, since I'm using wire, I ensure that my wires are tightly connected. Number 2, I ensure that when the readings, I'm not taking the readings. I disconnect it, or I remove the key. I will to avoid the battery to run down. I just remember that this, I ensure I avoid the what? I ensure I remove the key while the readings was not taken to avoid running down the battery. Another one, since I'm using ammeter and voltmeter, even I'm using potentiometer, then maybe I avoided error due to parallax. These are the things we need to know about the physics by 2025 practical electricity. The activity will be about the fourth experiment on electricity. And if another experiment again, we will bring it to your watch and you will see again. We are here for what we need from you is that Just keep on subscribing. Don't be viewing or watching our video. As you watch, you subscribe, you share the link. And God bless all of us. I still remain your English tutor, Apparatus. See you in the next video. Bye.